Hello there, chemistry students. This is our help video for page 2 of the 8-13I class notes packet, which you are to complete this week. In this particular reaction, calcium metal is going to be dropped into a solution containing iron 2 chloride. Remember, a solution means that the FeCl2 started out as a salt and was pulled apart by the aqueous solution. Water can pull apart the salt because water is partial positive, partial negatives on it, which will allow it to attract and pull apart the ions in the salt crystal. So here we are in container 1 right here. We are dropping in the calcium metal. Calcium's in family 2, and it has 2 electrons, which it can force onto a less active metal. If you look at your activity series, calcium is above iron on the activity series, which means that calcium is more active, so it will be able to force its electrons onto a less active metal. In these single displacement or single replacement reactions, the more active metal is able to force another less active metal to accept the electrons and become a neutral atom. So in this container right here, we have the iron. It starts off as 2 plus. It's floating around. The calcium metal's dropped in. In container 3, we're showing calcium forcing its 2 electrons onto the Fe2 plus. If Fe's 2 plus, it means it can take 2 electrons. So calcium forces its electrons onto the iron. Iron no longer has a charge. In order to stay in solution, you have to have a charge for the polar water molecule to hold on to and keep you in solution. Calcium now has a charge, so the polar water molecule is able to hold it in solution. The iron metal will precipitate out of solution. PPT means precipitate, and this means it's now going to be a solid. That's an S there, and it's going to be a solid. So our chemical equation then shows that for every 1 calcium atom, it will react with 1 formula unit of iron 2 chloride. Aqueous again means it's pulled apart. When we're done, the iron Fe has been replaced by the calcium in the compound. So iron is with the chlorides there. Now calcium's with the chlorides here. But aqueous once again means that they are pulled apart. So the calcium's floating around by itself. The 2 chloride ions are floating around by themselves. But in the compound, they're written together. An ionic equation shows what happens when we actually write what is in the containers. In other words, we pull apart the salt. So we start off with the calcium, and here we're pulling apart the iron 2 chloride. So the Fe2 plus is there, and the 2 chloride ions are here. We just pulled it apart in the ionic equation. How do we know the Fe's 2 plus? Well, look at the 2. It was crossed down from the Fe. Chlorides are 1 minus, so we only needed 1 Fe. So we have the 2 chloride ions, and when we're done, the Fe is no longer charged. The calcium is 2 plus. Uncross the charge, we'll see calcium's 2 plus, and we have the 2 chloride ions. Which ion did nothing in this equation? It's the chlorides. The chlorides did nothing in this equation. The element that had no charges change is called the spectator ion. So the chlorides are the spectator ion. In the net ionic equation, all we do is remove the spectator ion. You get rid of the one that did not change. Net means we're looking at what changed. So we just pull out the 2 Cl minuses, and we have the net ionic equation there. On the second reaction in this page, we have a metal reacting with an acid in solution. So in this reaction, we are dropping a piece of cadmium metal into an aqueous solution containing hydrochloric acid. So in this first container, we're getting ready to drop the cadmium in. there should be 2 dots on the cadmium right here because cadmium has 2 valence electrons to work with. So we're dropping cadmium in. Now you have to look on your activity series. If cadmium is above hydrogens, that means that the cadmium can replace the hydrogen. Remember, metals replace the first thing in the compound. The metals replace the positive ion in this compound right here. Hydrochloric acid is one of our 6 strongest acids. So hydrochloric acid will dissociate 100%. Every one of the H pluses will break off, leaving behind the Cl minus. So when a metal replaces hydrogen in an acid, what happens here is the cadmium's dropped in. It's more active than hydrogen, so the cadmium's going to force 1 electron onto each of the hydrogens. Remember, H is in family 1. It only has 1 electron to lose when it becomes H plus. So it can only accept 1 electron in this reaction. So the 2 H pluses end up with an electron. The cadmium loses both electrons and becomes 2 plus, as it's shown here in this container. Each hydrogen now has an electron, but still needs 1 more to become stable and satisfy the duet rule, where hydrogens need 2 electrons. So the 2 hydrogens each share 1 and become H2 gas, which will bubble right out of the solution. A characteristic thing that is observed when a metal reacts with an acid is the formation of H2 gas. You'll see the hydrogen gas actually bubbling out of the solution. So our chemical equation here, we have cadmium, solid, dropped in. HCl aqueous. Aqueous means that water pulls it apart. There's the H pluses, there's the 2 Cl minuses. The 2 in front is telling us we're going to have 2 H pluses and 2 Cl minuses. And when we're finished with the reaction in container 3, the H2s break off as hydrogen gas, and we're left with CdCl2 aqueous. Aqueous means pull them apart. Cadmium's 2 plus if you uncross it. The subscript by the cadmium is 1, which means the chlorides are 1 minus. And that is explaining why we have these ions and hydrogen gas in that third container. In the ionic equation, we're just going to pull apart HCl into the 2 H pluses and the 2 Cl minuses. The ionic equation, you're writing what is actually in container 2. We start off with a cadmium, 2 valence electrons, 2 H pluses, and 2 Cl minuses. Our product here, on the right side of the arrow, we have the H2 gas, and again, aqueous in the ionic equation, we pull it apart into the 2 Cl minuses and the cadmium 2 plus. So we're just writing what is in the third container on the right side of the arrow. Who did nothing in this equation? The chlorides did nothing. They just sat and watched it happen. They sat and watched the more active cadmium force its electrons onto the less active hydrogen ions and did nothing about it. The spectator is Cl minus. The net ionic equation, you just remove the one that did not change. Net means we're looking at what changed. So we pull the 2 chloride ions out and we just write the elements that actually had their charges change. In one of our upcoming notes, we will realize that what is really happening here in a single displacement or replacement reaction is a redox reaction. It's an example or a specific type of redox reaction, an oxidation reduction reaction, which means charge is changing. Hopefully, this will help you understand what happened on page 2 of our notes. If you have any further questions, anything specific that you would like to discuss, email, and I'll be happy to get back to you. Have a great day.